Hey friends, Dr. Borole is here. Today we will see the gas sensors and light sensors. The various types of gas sensors are the combustible gas sensors, ultrasonic sensors, electromechanical sensors, semiconductor sensors, photoionization type of sensors, and infrared imaging sensors. Those are mostly used in detection of gases. Whereas the semiconductor sensors are mostly stressed in your syllabus. Let us see the semiconductor gas sensor. The semiconductor gas sensors are based on the chemical reaction of the gases with the sensor materials. The most commonly used materials for semiconductor gas sensor is tin dioxide, SnO2. The tin dioxide resistance is decreased from 50 kilo ohm in open air to about 3.5 kilo ohm when it is subjected to 1% of methane gas. So, tin dioxide can be used for detection of methane gas. The change in resistance of the sensor is used to calculate the gas concentration. Some of the gas sensors are oxygen gas sensors, hydrogen gas sensors, carbon monoxide sensors, LPG and CNG detecting sensors, alcohol vapor sensors. Whereas carbon monoxide sensors are quite common in the exhaust carbon monoxide detection in the vehicles we are observing in our day-to-day life. Following table list some of the common material used for the gas sensors. For example, ZNO, zinc oxide, that is sensitive to H2S gas. ZNO and SNO2 is sensitive to oxygen. Titanium oxide is sensitive to NO2. See, SNO2 is also sensitive to LPG gas. Titanium oxide is sensitive to carbon monoxide and so on. So this list is quite long and various materials are used for detection of different types of gases. The application areas of various gas sensors. For example, they can be used in breath analysis, emission measurement in vehicles. They can be used for vapor detections of various materials and gases. They are used in hazardous safety systems. They can be used in refineries and industrial plants, commonly used in paper and pulp industries for safety protections. Wastewater and facilities can also utilize the gas sensors. Paint manufacturing plants are also finds the application of gas sensors in safety systems. The typical alarm system of gas detecting sensor is shown below. Here, the area to be monitored is shown in which the gas sensor is installed. We can commonly see such type of application in colleges and academic institutes also where the people gathering is. In the protection system, the sensor is normally installed on the rooftops Under normal condition, the sensor output is null. When a hazardous gas is detected or fumes or smoke is detected, then the gas sensor output is changed. This change in the sensor output is compared with the threshold limit in the signal conditioning circuit, and alarm will be generated if the signal crosses the threshold limit. Sometimes display facility of percentage of the gas detected is also displayed by the system. That's all about the gas sensors. The next sensor we will see is light dependent resistance. It can be a photoresistor or it can be a photoconductor. Light dependent resistance is used for detection of light. The LDR resistance is dependent on the light intensity fall on it. The LDR works on the principle of photoconductive effect. Its resistance decreases with the increase in the intensity of incident light. LDR is an optical sensor. As we know, in the photosensitive material, when the light photon falls on the material, they gives the energy to the atoms, and the charged particles in the atom, they are jumping in the conduction band, and therefore conductivity of the material changes. So higher the intensity, higher number of charged particles are available in the conduction band. And therefore, in photosensitive semiconductors, when light falls on the material, its resistance is decreased, that is, conductivity is increased. And the change in this conductivity is proportional to the light intensity that is incident on the photoconductive material. It should be noted that the conductivity and resistivity is wavelength and material dependent, and therefore for different lights in the light spectrum, the different material can be used for detecting it. The basic principle is photon generated charge carriers. Just explain. A typical construction is shown in the following figure. It consists of a light sensitive material and a glass window. From this glass window, the light will incident on a material. When the light falls on the material, its conductivity between the two terminals provided here changes. The change in the conductivity means there is a change in resistivity that can be detected by the signal conditioning circuit. And mostly that signal conditioning circuit is a Wheatstone bridge. The symbol of a LDR is shown here. The symbol is showing a resistance and the arrow indicates the light fall on it. So it is light dependent resistance. The physical appearance is shown for the practical LDR here. The following figure repeats the operation visually. See, when the conducting bar is excited with the external potential, initially the resistance of this material bar is large. When photon incident on the material bar, they will break the covalent bonds and generate the electron hole pairs. Those are available for the conduction, and therefore resistivity of the bar is decreased, which is proportional to the incident photonic energy. The characteristics of LDR is shown in the figure. It is the approximate characteristic shown. The characteristics are mostly non-linear. Here, approximate linear segment is shown. On x-axis, there is a intensity in lumen per meter square, whereas on y-axis, there is a resistance in kilo ohm. When the sensor is in dark, means no light is fall on the sensor, the resistance is maximum. When the light intensity is increased, the resistance of the sensor is decreasing, and it changes from hundreds of kilo ohm to few hundreds of ohm practically. Some of the advantages of LDR are they are having very simple construction and easy to operate and rugged. They are good sensitivity to the incident light. They are cheaper and they are having approximate linear response with the light intensity. Some of the disadvantages of LDR are there exist a light memory effects or light history effect in LDR. So due to this effect, the resistance change is slower when the light falls on it, and therefore response of LDR is slower. Rapid changes in light intensity are difficult to measure by using LDR. LDRs are working only over the small range of electromagnetic spectrums, and therefore they are sensitive to a particular wavelength only and cannot be used for wider range of electromagnetic radiation detection. Various applications the LDR founds in the following areas: camera exposure controls, the photocopy machines for checking the density of the toner, colorimetric test equipments, automatic rear view mirrors in the car, automatic headlight dimmers in the car, night light control, and street light controls are the few examples of LDR. A typical application of photo relay using LDR is shown here. We have seen this circuit earlier in the chapter on components. In this circuit, a transistor is used in the switching mode. Resistance R1 and LDR forms a voltage divider here, and voltage across LDR is connected to a BJT as input. The BJT is driving a relay coil. Diode used here for freewheeling the magnetic energy stored in the coil when the transistor is on. So during off state, the coil voltage will be clamped to 0.7 volt of the diode and therefore avoids the high voltage kick across the transistor. The contact part of the relay is shown in the second part of the circuit. The contact is connected in series with the mains, and in series with the contact, the lamp load is connected. Now how the circuit works? For example, during daytime, since the light intensity is high, the resistance of LDR is very low, and therefore voltage across LDR in this circuit is less than the turn on voltage of this BJT switching circuit. Therefore, BJT remains in the off state, relay remains de-energized, Contact remains open, and therefore in daytime the lamp will be disconnected, so lamp remains off. In the evening time, when the light intensity is decreasing at a particular cutout intensity, the LDR resistance is sufficiently high to produce the sufficient voltage to turn on the transistor switch. When the transistor switch is on, the relay will get energized. And when relay get energized, the contact will be closed. Once the contact is closed, the AC mains will supply the lamp load and light turns on. Again, through the night, the lamp remains on. In the morning time again, the light intensity is sufficiently high that turns off the transistor and automatically turns off the light. And this system works automatically by sensing the light intensity during day and evening time to control the lamps. This way, LDR can be used for automatic street light controls or room light controls in the night. That's all about LDR. We will see the next sensor in the next session. Thank you. Bye bye, friends.